We can extend our previous simulation to include another type of obstruction to better match the real bone structure. Back in Workbench, right-click on the fluid flow label in our previous simulation and select Duplicate. This will create an identical simulation that we can use as the basis for our new additions. Double-click on the name and rename this New Obstruction to help keep the project organized. Next, double-click on Geometry to open the model in Discovery again. Once Discovery opens, we can see our previous geometry in the window. We want to create the new obstruction downstream of the previous pillars. To start, click the Design tab in the top bar and select the Sketch option. Rotating the model by clicking and dragging with the middle mouse button. We can select the x-axis to begin sketching in the YZ plane. Press the V key to orient the view to be facing this plane. I find it more intuitive to have the inlet on the left and the outlet on the right, such that the flow moves from left to right. So, using the middle mouse button to rotate the model, I will orient the model to be close to this view and press the V key to orient the view to be facing the plane and to straighten up the axes. This makes it easier to create the desired sketch. We can begin sketching by selecting the Line tool in the top bar. Hover over the line representing the outer circular boundary until it is highlighted, and left-click to begin creating a line. Move your cursor downward and click again to create the line. We want to create a triangular shape, with one of the sides lying on the outer edge. So move your cursor over this line again until it is highlighted, and left-click to create another line. Finally, click the starting point of the original line to complete your shape. To avoid sharp corners, we want to round the corner of the far point of this triangle. To do this, select the Rounded Corner tool in the Sketch options. Click near the point on the left edge of the triangle, and click again anywhere on the right edge. We can see that this has rounded the corner, which we can modify later. We want this triangle to be isosceles, so we can add construction geometry and constraints to the sketch. Start by selecting the Line tool again. Hover over the top side until you see a small triangular marker appear, indicating the midpoint of the line. Left-click this point to begin creating it. And click again anywhere on the edge of the rounded corner. We will use this line to both constrain the geometry and create the three-dimensional obstruction later. Next, click Constraints in the top bar, and select Perpendicular. This will constrain two sketch elements to be perpendicular to each other. Start by selecting the line we just created, and then click the edge of the rounded corner. We can see that the geometry has been changed to accommodate this constraint. We next want to force this line to be straight so that the rounded corner is centered on the horizontal edge. To do this, select Constraints again and click Horizontal. This constrains a given sketch element to be horizontal. Because of the chosen orientation of our sketch relative to the origin coordinate axes, to make this line lie along the radial direction, we must constrain it to be horizontal. So click on it to constrain it. If this does not have the desired effect, your sketch may be oriented differently than mine relative to the coordinate axes, and using the vertical constraint tool will work instead. With this complete, click Escape to exit the tool. This line is only used to constrain the geometry and does not correspond to a physical edge. To indicate this in the software, right-click on the line and select Construction On/Off. This toggles the line to be a construction line. We can see this because the line has become dashed. This also allows us to use this line to make a revolving cut later. We can further constrain this shape using dimensions. Select the Dimension tool in the top bar. Start by clicking the horizontal edge, and clicking again to create the dimension. Next, select the leftmost point of the triangle to begin creating a dimension, and then click the rightmost part of the pillar to create a dimension for the gap between the obstructions, and click again to create it. Next, click on the rounded corner to create a dimension for its radius, and click again to set it. Next, press Escape to exit the Dimension tool. We want this obstruction to extend between the inner and outer surfaces. To do this, hover over the construction line and click and drag on its endpoint to move it below the inner radius. In this configuration, we can select the Dimension tool again to constrain it. First, click on the rounded corner, and then click on the inner edge. We can then click again to create this dimension. Next, we can click these dimensions to edit them. Make the length of the triangle base 80 nanometers. We can see how the sketch has changed to accommodate this dimension. Next, the dimension between the obstructions is 75 nanometers. The radius of the rounded corner is 5 nanometers. And finally, the bottom spacing is 1 nanometer. With the geometry fully constrained, click 3D mode in the top left to finish the sketch. If we zoom out using the scroll wheel, we can see that returning to a 3D view makes it hard to see the surface created by our new sketch. To fix this, select Section Mode in the top bar and click on the x-axis to view the same cross-section we were sketching on. This allows us to better view and manipulate the surface to create the obstruction. Again, press V on your keyboard to orient the view to be facing this plane if the orientation got altered. Similar to before, we will use the pull tool to create the bump. With it selected, we can now click the surface we want to use. It can be hard to select the surface on the geometry itself, so instead, click Surface in the design tree. We can see that it is highlighted in our section plane view. Before, we used the standard pull operation to create a hole in the solid geometry. This time, however, we want to revolve our sketch around an axis to create the cut. To do this, select Revolve in the options near the selection. Since we want to cut into the original geometry, select Cut under the pull options like before. Finally, we need to select the axis about which to rotate the surface to create the cut. In the tree, expand Curves, and click on Construction Line to select it. We can then make the cut similar to before. Use the middle mouse button to rotate our view so that we can see the top of the model. Then, left-click on the yellow circular arrow and drag it slightly to begin the cut. Click spacebar on your keyboard and enter 180 degrees. This creates the full revolution cut. With this complete, click Escape twice to exit the tool, and click 3D mode in the top bar to view our whole geometry again. Rotating the model using the middle mouse button, we can now see that the obstruction has been created as desired. In order to apply boundary conditions to this new feature in Fluent, it needs to be included as a named selection. As before, select the Name Selection tool in the bottom left. Use the middle mouse button to rotate the view so you can see the top of the geometry. And start by clicking on the large face of the new obstruction. Next, zoom in near the obstruction. Hold Control on your keyboard and select the smaller round face. Back in the Name Selection tool, create a new name selection and name this Wall Bump. This completes the new geometry addition, so we can close Discovery. Back in Workbench, the new model can be meshed and solved similar to the previous simulation. Because the geometry changed, we will need to create a new mesh, however. This process can be completed as before, but making sure to include our new name selection for the bump in the obstruction sizing. Make sure to save your project.